first concept that we'd like to talk about today is called lipotoxicity. So here's my question to you. Will, what the heck is lipotoxicity?
Lipotoxicity is a fascinating topic that I'm very excited to talk to you guys about today. And I'm guessing that people who are regulars on the Mastering Diabetes Network have heard of this concept. I'm sure that many of you have read the book Mastering Diabetes and read about this concept. But I want to come at this and talk about it from a gut microbiome perspective. And to get there, I think we need to start off with the basics, because basically the information that you're going to hear here today, you will know more than your doctor by the end of this conversation. And that's the honest truth. And that's not me trying to be hyperbolic. That's me telling you that I've never heard another doctor talk about this, yet there is a world of medical literature describing this. So what the heck is lipotoxicity? The body thrives on balance. This is so true of the entire, everything about the way that we work as humans. And, you think about, for example, the heart and rhythm. When the heart is in rhythm, we are capable of incredible things like running marathons. But you could take a marathon runner, put that heart out of rhythm, give them an arrhythmia, and they can't even walk up a flight of stairs. The gut thrives on rhythm. That's one of the really key things that I've discovered in my career taking care of patients, is that when you get people into a rhythm from a gut perspective, they just seem to do better and everything falls into place. Digestion is better and they're enjoying their food and life is good. There is a balance and a rhythm that exists when it comes to the way that we handle our fat. We all have fat in our diet. Even plants have fat. And the way that we maintain our fat balance is very important to our metabolic health. And lipotoxicity is when our fat balance no longer exists. In fact, we have lost balance. And what we have is that either there's an excessive production of fat within the body, we're going to call these free fatty acids, or you're not getting rid of these free fatty acids the way that you're supposed to. So as a result, too much production of free fatty acids, or not getting rid of the fatty acids, you have an excess of these free fatty acids, and this leads to downstream consequences. So when we talk about lipotoxicity, I think it's important to first sort of unpack this a little bit. Let's go into production. It's not just production of free fatty acids, although it could be. Production can be when we mobilize fat from our fat stores. But it can also be a juicy burger that someone eats that's laden with saturated fat, or it could be someone eating Crisco, which is laden with trans fat. And these fats, particularly saturated fats and trans fats, they drive up dramatically our fatty acid levels in our blood. So anything that drives up our fatty acid levels is going to create a strain on the body to try to balance it out. How do we get back to balanced? The way our body gets back to balance when we drive up our fatty acid levels is either by burning fat or by storing fat. And the number one place that we store fat are our fat cells, which are adipocytes. Now, here's the problem. Our adipocytes are like balloons when it comes to fat storage. They can swell until they reach a certain point of tension, and then actually they start to collapse a little bit. They squeeze. You can only put so much fat into the fat cells. So when we need to get rid of this excess fat that we have driven up through the consumption of saturated and trans fats, we turn to our fat cells, but what if they're completely full? We have a problem. If your fat cells are completely saturated, then you need to put the fat someplace else. This is inherently the problem that exists that we describe as lipotoxicity, where you have an excess production, an excess high level of fatty acids in your bloodstream, and you have nowhere to put them. And so you push them into, I'm going to name 5 places. I'm going to name 5 places. Muscle, liver, pancreas, heart, kidneys. 5 places that we go to hide the fat. When we have an excess of fat, we need a new place to hide it. It goes into one of these 5 places because we can't put it into our adipocytes, our fat cells anymore. And the problem is that this fat that shows up in these places, it's not supposed to be there. And it causes dysfunction of the cells. And they stop working the way that they're supposed to. So I named 5 places: muscle, liver, pancreas, heart, kidneys. Let me start with the last 2 real quick. Lipotoxicity has been associated with coronary artery disease. That's our number 1 killer. Lipotoxicity has been associated with congestive heart failure. Fat in heart cells is not good for us. Lipotoxicity has been associated with chronic kidney disease. That's a top 10 killer. Fat in kidney cells is not good for us. Now let's take on the last 3, and then I want to open it up for conversation with you guys. Let's take on the last 3, which are muscle, pancreas, liver. All right, so these 3. It turns out I have just named the critical 3 endocrine organs in terms of blood glucose regulation. If you want to maintain your blood sugar, you need healthy muscles, healthy liver, and a healthy pancreas. And when you start jamming fat into pancreatic cells, the beta cells, which release insulin, become incapable of producing the insulin that they're supposed to. You already are starting to mess up your blood sugar response. And when you jam fat into liver cells, you affect gluconeogenesis, which is the production of sugar. You affect the balance of the sugar within the body. You create the deposition of fat within the liver. This is non-alcoholic fatty liver disease, by the way, which is soon to become the number 1 cause of cirrhosis in the United States. And you actually cause direct injury to the liver cells. And finally, most people don't realize this unless they have read this book right here, Mastering Diabetes, which makes it very clear, and everyone needs to know this. 80% of excess glucose after a meal ultimately ends up getting shunted into muscle tissues. Our muscle is an endocrine organ. Most people don't think of it that way. We just think of it as something that helps us to push and pull. But actually, this is an active endocrine organ. It is involved in glucose balance. And when you start cramming fat into muscle cells, you take away our reserve capacity to basically take sugar out of our blood and store it in our muscle cells. This is why we get insulin resistance. And diabetes is one of the top 10 causes of death in the United States. So, I realize that I'm preaching to the choir here, but lipotoxicity is connected to insulin resistance, to diabetes, to coronary artery disease, to congestive heart failure, and to chronic kidney disease, not to mention, again, preaching to the choir, that insulin resistance is connected itself to high blood pressure, to high cholesterol, to gout, to chronic kidney disease, to fatty liver disease. I could keep going. The point being that we are talking about something that's very important for metabolic health.
Absolutely. So I'm glad to hear you talk about lipotoxicity in grave detail here, because I feel like this one concept is responsible for so many satellite health conditions, and yet the overwhelming majority of medical practitioners don't fundamentally understand what lipotoxicity is, and secondarily, they don't understand what effects can result in many tissues from a lipotoxic environment. So you named multiple tissues that can get affected, right? Your liver, your muscle, your pancreas, your kidney, and the 5th one was your heart. Thank you. All 5 of those, right? Absolutely. There's no question about it. There's also there's a whole body of evidence now that the Scher's eyes have also uncovered that lipotoxicity can also affect your brain. And it affects your brain in a different way than it does the rest of your peripheral tissues. But as a result of that, you can actually develop what's called insulin resistance of your brain, which can then set you up for cognitive decline down the road, 20, 30, 40, 50 years into the future, right? So I remember when I was getting my PhD back in 2012, and I was in a scientific discussion with a whole collection of colleagues, and there was this light bulb that just came off in my head where a researcher was explaining that it's not that your liver, your pancreas, your blood vessels, your muscle tissue, and your kidneys are incapable of storing fat, because they are biologically designed to be able to store glucose, to be able to store fatty acids, and to be able to utilize, let me back up. They're biologically designed to be able to utilize glucose, utilize fatty acids, and utilize amino acids for energy. They all do have slightly different mechanisms by which they do it. But the idea here is that fatty acids are a fuel for all tissues, period, end of story. The problem of lipotoxicity happens when when these tissues become overwhelmed with excess fatty acids from your diet. Okay, so it's not a question of getting to a zero fat diet or getting to a hyper low fat diet. That's not what we're suggesting. Effectively, what you're talking about here is lipotoxicity results from an excess of dietary fat, which then results in an excess of fatty acids being stored in multiple tissues, causing a global lipotoxic environment. So this is very, very, very important because, as you'll go on to explain, I think, is that there's also a direct connection between a lipotoxic environment and what can happen inside of your gut, correct? Because we haven't even talked about your digestive health at this point, but your digestive organs and the bacteria inside of your large intestine in particular can also be negatively affected by a lipotoxic environment. Is that correct?
Yeah, that's correct. I think that the thing about when we dig into these topics, the work that you did when you were pursuing your PhD, we look at things in isolation because we have to. That's the way that we study things. That's the way that we understand things. But the reality is that the body doesn't work in isolation. Everything is intertwined and interconnected. And literally right this very moment, our body is processing fat, and there is a fat balance that takes place within us. And right at this moment, we have a gut microbiome filled with 39 trillion microbes that are actively working on different things, including potentially our body fat and, things that could downstream lead to lipotoxicity. So, everything is intertwined. And the reason that we keep coming back to this concept of gut health, and we talk about how, all health begins in the gut. You hear people talk about this type of idea. The reason why is because these gut microbes have proven to be critically important to so many different biological processes within our body, including our metabolism, including our fat balance, including things that could lead to lipotoxicity, but also including our immune system and our hormonal balance and our mood and our brain health and our genetic expression. They're so critical. They're so central to everything that matters to human health. If we zoom in on these gut microbes and we start talking about how our gut microbes play a role in fat balance, in lipotoxicity, let me start off with some basic, simple, easy to understand research studies that are out there and are not hard to find. If you take a mouse that is what we would describe as germ-free, which means these are specially bred mice that do not have a microbiome. They're completely sterile, like all the way through, including inside their gut. This mouse is borderline incapable of inducing diabetes and insulin resistance. It is extremely difficult to induce insulin resistance in this mouse that has no microbes. Interesting. That implies that the microbes matter. All right, now, if you take one single bacteria and you introduce this single bacteria into this germ-free mouse, so now it doesn't have 39 trillion microbes, it has one species. If it's a properly selected species, and there's a specific one that's called Enterobacter, if you introduce this species, this mouse will become obese, it will develop insulin resistance, and it will have increased inflammatory levels in its body by quite simply introducing one species. Third study, if you take a mouse that has a microbiome and you treat this mouse with antibiotics, you can reduce an inflammatory molecule called lipopolysaccharide. All right, some people refer to it as bacterial endotoxin. And in doing this, you can actually reverse insulin resistance and the mouse will lose weight by changing the microbes. So now this goes to show you the potential power that exists within these microbes, which is to say that if you have the wrong mix of microbes, they put you at risk for developing insulin resistance and lipotoxicity. If you have the proper balance of microbes, they can actually protect you. And we know from multiple studies at this point that there's specific types of microbes that exist within people who are obese. These are microbes that are really good at harvesting energy, extracting every single calorie that they could possibly extract. And there's different microbes that exist in people who have insulin resistance and type 2 diabetes. The person who has type 2 diabetes has inflammatory microbes like E. coli, and they are missing the anti-inflammatory microbes like Fecalibacterium prosnitzii that produce short-chain fatty acids. So what I'm trying to say here is that it comes back to this gut, comes back to the gut, comes back to the gut microbes, and the balance of the microbes can affect the balance of your fat within your body, which can affect insulin resistance and all these downstream events. So it really kind of starts in a way in the gut. And the way that you get these inflammatory microbes like E. coli that cause lipotoxicity, it's no surprise. You consume saturated fat. You consume an inflammatory diet. And it's no surprise that this happens to be the same diet that's been associated with insulin resistance and type 2 diabetes. So on the flip side, if we want to look at like how do we actually empower our gut microbes to reduce insulin resistance, to rebalance in terms of our fat balance, how do we do that? We need more anti-inflammatory microbes, and we can dig in more into the value of short-chain fatty acids. But the quite simple solution is to empower and fuel your gut microbes with their preferred food, which is fiber.